So what this means, and what we're going to talk about today, is the definition of a continuous function. It has three parts. So with any function, we have where c exists, where the limit of f of x as it approaches infinity exists. And what that looks like in terms of notation means the limit as x approaches whatever value that you have of f of x exists, meaning the left hand and right hand have to equal each other to produce the limit. And then finally, part 1 and part 2 are equal. All right, let's take a picture. So we have three things going on this graph. The first one you will see on the left-hand side, this graph has an asymptote, and this is called an infinite discontinuity. The next one that we have is over here where there's a space between those, and that one is called a jump. And then the last one is where we have this hole, and this hole is called a removable discontinuity because I could add something in there to fill that hole. All right, let's look at some examples with this. All right, so if we look at f of x here, what we see by looking at the denominator, that we know that x cannot equal 2. Now, that means that it is not continuous at 2. And this is actually an infinite discontinuity. Now, if I look at the next function, function g, as I look at g of x, before I can go ahead and decide what I have to do, I have to factor, and that becomes x minus 1 all over x plus 2 times x minus 1. Now I can go ahead and look at the domain of that, and from the domain, I get that x cannot equal negative 2, and x cannot equal 1 in my domain. So I know they're both discontinuous at that point, but when I go ahead and make this reduction, what that happens is that gives me a hole at 1. So what I can say for this part is the function is not continuous. At negative 2, at x is equal to negative 2, and x is equal to 1, but we do have a removable discontinuity. At